Hello everybody, and welcome back to another geometry lesson. Today we're going to take a look at lesson 11.1, which is going to be all about circumference and arc length. Some of you may have heard of circumference before. The circumference of a circle is just the perimeter of a circle. Oops, this pen is dying a little bit. Great start. It's just the perimeter of a circle. But it can also be thought of as distance around a circle. Both of those are appropriate ways of describing the circumference. So let's draw ourselves a circle here. I'm going to give it a center right here. And I'm going to make it about, let's do yay big. There we go. I'm going to call the center point P, and I'm going to put a couple points around it. Don't mind these too much just yet. I'll give it points A, B, and C. To find the perimeter of a circle, to figure out how long this distance is, it's going to end up being an answer in terms of inches or feet or millimeters or whatever may have you. In order to do so, we need to use this, a radius. Once you have a radius set in mind, the circumference actually has a formula you can use. The circumference of a circle, C, is given by the formula 2 times pi times the radius. So, just by knowing the radius, you can figure out how long this distance is. Keep in mind this is something a little bit different than degrees. Keep in mind, a circle is always going to have 360 degrees inside of it. So we can have a circle here. We still know that its total total arc measures add up to 360, but its circumference is going to be something else. Another thing we may notice is this formula here, circumference equals 2 pi r, has something we can simplify. It involves this 2 and one of the other pieces here. Can we spot it? Well, since 2 times the radius is just the name of the diameter, C could also be pi times the diameter. Again, because the diameter is just 2 times a radius. So as a quick little example here, let's say I gave you a circle with a radius of 5. The circumference would be 2 times pi times 5. And since 2 times 5 is 10, we could write our answer as 10 pi. Usually, we will also want it as a decimal, so if we were to multiply 10 times pi, you get 31.42 about. But 10 pi is a perfectly reasonable way of writing our answer here. Let's take a look at a couple examples like this. So here we have exercise 1, which is asking us to find the circumference of a circle with a radius of 7. Well, we know that if a circle has a radius of 7, we can use the formula that involves our radius, 2 times pi times the radius. Instead of the letter r, though, we can input our radius of 7. Again, we look and see what we can combine here, and 2 times 7 is 14, so this will be 14 pi. If we want to plug 14 pi into our calculators, here is how we can do it. We'll type in 14, and then right underneath the clear button, right here, you'll see there's a blue pi button. If you click second and then that button, you'll get pi. And 14 pi is about 43.98. So, our answer for the circumference is about 43.98. But 43.98 what? Inches? Miles? Coconuts? Whenever we are dealing with these problems, the measurements will often have units. In this case, the radius was 7 centimeters long, so the circumference is 43.98 centimeters. What could we do with a problem like B, though? B wants us to find the radius when we are given the circumference. Well, in this case, to find the radius of a circle, we'll just use the same formula. Circumference equals 2 pi r. Except this time, we know our circumference. The circumference is 36. So 36 equals 2 pi r. Now we can just use some algebra skills to simplify. To get r by itself, we have to get rid of this 2 and this pi by dividing. So why don't we just divide by both at the same time? If I divide by 2 pi, the 2 and the pi will both cancel. I just have to do it to the other side. So r equals 36 over 2 pi. We can technically simplify this a little bit, but I just want to show you how to plug it into the calculator. Be careful, because this is a common error that I see. I'll see people plug it in like this, and then scratch their heads. Because how is it possible for the radius to be 56 if our entire circumference is only 36? That answer is incorrect because we typed it into the calculator wrong. What the calculator saw that answer as was, 36 divided by 2 with a pi at the end. Do you see how these two could be interpreted as the same thing? We don't want that. To guarantee that we get the right answer, we can either type it as 36 divided by parentheses 2 pi. That's one way to fix it. Or we can type it in as a fraction using the green fraction squares up here. Press the green alpha button and then the x, t, theta, n button, and it'll make a fraction for you to input your expression. 36 over 2 pi is 5.73. So our radius is approximately 5.73. Since the circumference is meters, we know it's also going to be in meters. Very nice. Now, at this point, I want to take a look at the second definition for today's lesson, arc length. The arc length of a circle is going to be this formula here, which looks crazy. But I want to explain what arc length is first so we can try to contextualize it. In fact, I'm going to put it on this diagram. Let's pick an arc. Let's go from A to B, for instance. There are two ways we could measure this arc. The measure of arc AB, as we know from last unit, is going to be some degree. It's going to be like x degrees. Frankly, from the diagram, it looks like it might be around 110 degrees. But we also have the length of AB. So once again, that's the measure of the arc. The length of an arc, denoted by L of arc AB, is going to be some distance. Maybe it's x inches, x miles, or just x units. So how on earth can we figure out how long this arc is? First off, I want you to imagine it instead like this. Say we have a circle. We'll call this circle P. And I'm going to place an arc on it, AB. You don't need to write this down, but I want to show you. I've specifically made this arc so that when I connect it up with radii, let's look at the central angle it makes. It makes a right angle. So we now know the measure of this arc, because the measure of an arc matches the central angle. The measure of AB is 90 degrees. The thing is, this is 90 degrees out of the total degrees in a circle, which is 360. We now know that arc AB is a quarter of circle P. Let's say I happened to give circle P a circumference, though, a total length. Let's say I told you that the circumference of circle P is going to be, I don't know, let's call it 40 centimeters. So the entire path around circle P will be 40. Didn't we just say that arc AB is a quarter of circle P? Well, what's a quarter of 40? Since a quarter of 40, this marker is also dead, since a quarter of 40 is going to be 10, we can say that the length of AB equals 10 centimeters. There is a relationship between the measure of an angle, the measure of an arc and 360 degrees, just like how there is between the length of an arc and the circumference. In fact, those two are directly proportional. This means we can set up a proportion to solve it. Let's say, for instance, that we didn't know that AB was a quarter of P. Let's say we called this length x instead of 10 centimeters. We could say that just like how 90 divided by 360 is 1/4, so should x divided by 40. And we could cross multiply to solve. So that's the main idea behind the formula we are going to use down here. The formula is the arc length of AB divided by 2 pi r equals the measure of arc AB divided by 360. Let's fill in this definition of arc length, since I don't think we gave a formal definition for it, but it is the ratio of the length of an arc to the circumference. We can write arc length by making this proportion, making these ratios, and solving it. So let's take a look. The formula says the arc length of AB divided by, wait a second, we know that this is just the circumference, equals the measure of arc AB divided by 360. Basically, take the portion of the circle divided by the circumference. It'll equal the portion of the arc divided by 360. Let's take a look at example C to see what we can do. To find the arc length of arc AB, we need to compare what we know and what we don't. We'll be setting up a proportion for this. And the proportion goes, the arc length of AB, which we don't know how many centimeters that is, so we'll call it x, divided by the circumference of the circle. We don't know that, and we'll need to figure it out, so I'll leave it blank for now. Equals the measure of arc AB. In this case, could we find the measure of arc AB? Well, since the central angle is 60, the measure of the arc should also be 60. So 60 degrees divided by 360. Perfect. The only piece of this puzzle that we were really missing was the circumference. So we can use our formula, 2 pi r, to find the circumference. Since our radius is 8 centimeters, 2 times 8 is 16, our circumference is 16 pi. Leave it in this form until you are ready to solve for x, so you don't have to worry about rounding. With that said, we can now cross multiply. 16 pi times 60 is going to give us 960 pi. X times 360 is going to give us 360x. Simply divide both sides by 360, and we will get an expression for the arc length. The arc length of AB is x equals 960 pi divided by 360. Of course, we want to actually know what this crazy fraction equals, or about what it equals. So 960 pi divided by 360 gives us 8.38. 8.38 centimeters is going to be the arc length of A to B. Very nice. Let's take a look at E. This time, part E is asking for the circumference of circle Z. So we can still set up our proportion. It's just the stuff that we know and don't know are going to be a little bit different here. In this case, do we know the arc length? Well, we actually do. The arc length is going to be 4.19 because it's given to us. Down below, since we don't know the circumference, that's what we're trying to find, we can call it C. Do we know the arc's measure? Well, since the central angle is 40, the arc's measure is 40 degrees. And finally, it's all over 360. Once again, we can just cross multiply to solve. 4.19 times 360 will be on one side, and 40 times C will be on the other. Divide both sides by 40, and we get an expression for C. C will be 4.19 times 360 divided by 40. Our circumference, C, is about 37.71 inches. Very nice. I want you to pause the video and try out problems D and F. Give it a shot and check your answers in just a moment. How did we do? As we can see here, the arc length of PR was 20.94 inches. The measure of RS is 164.99 degrees. If you have any questions about these, please let me know. I'm happy to go over them with you. With that said, though, we have the last problem of this small section. Exercise 2. The dimensions of a car tire are shown, and we want to figure out, to the nearest foot, how far the tire travels when it makes 15 revolutions. What's a revolution? Well, for those who are unaware, a revolution of a wheel is what happens when a wheel starts in a certain place, turns, and ends in the same position. So here's an example. I've got this part of my tire, this little dot, on the very bottom. If I was to rotate this wheel down the road bit by bit like a wheel, it's going to keep on turning and turning and turning, and eventually it'll reach sort of the same state. That's a revolution, is when it can turn all the way around and return back to the way it once was. But we may have noticed something. If the wheel gets to spin, or the tire, I should say, gets to spin all the way around 360 degrees, don't we have a name for that? One revolution is a circumference, because each part of the wheel, each part of the tire, I should say, gets to touch the ground. So, 15 revolutions is another way of saying 15 times our circumference, c. All we have to do is figure out what our circumference is. That's where these dimensions come in. Folks, the circumference of a circle is 2 pi r, but we aren't given a radius here or a way to find a radius, so that's out. But we do have a second formula. The circumference of a circle could also be written as pi times the diameter. And in this case, we do have a diameter. The diameter is going to be all of these lengths from the top of the tire all the way down to the bottom of the tire. That is going to be our diameter. So what's 5.5 plus 15 plus 5.5? That'll give us a diameter of 26. So our circumference is 26 pi. Multiply that by 15 and we will get our 15 revolutions. 15 times 26 pi gives us 1225.22. And what's the units? Well, these are in inches, so this is in inches. There's just one problem here, which is we wanted to figure out the distance to the nearest foot. Not to worry, though. To convert something from inches to feet, we know that since there are 12 inches in a foot, you can just divide by 12. If we take our answer and divide by the 12 inches there are in a foot, we will get 102.10 feet. There we go. Thank you so much, folks. That concludes 11.1. Have a fantastic rest of your day.